And we're live. Hello. And can you hear me?
I can. Hello.
Yes. Hi. Welcome to AmalAfrica. My name is Sam Elamine. I'll be guiding through today's webinar. I'm actually the founder of AmalAfrica, and our goal really is to bring more work opportunities to the people of Sudan. On today's webinar, we have a very good friend of mine, Sebastien Lambda. Sebastien has been working with software, and he's been building websites for as long as I can remember. I don't know if it's been 20 odd years.
we don't count. We stopped counting.
And today he's going to be talking to us about software and why we are doing it wrong. So Seb, I'll pass it over to you.
Rightio. Well, thank you everyone for coming and for listening. I'm sorry I'm not 100% because I've been sick in bed for about a week. So if I feel a little bit slow at times, that's the reason. Sam is absolutely correct. I've been building software for way too long, probably. I think I wrote my first code in the first piece of code that I got paid for in the late 90s. So it's a little bit of time. And over time, I've tried about every single kind of projects, every single kind of company, most kind of methodologies. I've been doing agile methodologies since the early 2000s, and there's something that dawned upon me over time, and that thing is that we're not being very successful at building software because we're doing it absolutely all wrong. And I dropped accidentally into a survey on the internet that is done on a regular project by it's a survey by Not Us, and basically asks people, are your projects successful or are they failing? And the majority of people, I think it was 55 to 60% of people, say that their project is failing. It's not on time, it doesn't do the right thing, it's over budget, whatever. There's always something that makes the project as a whole not successful. Of course, that's not limited to IT projects, because what's very interesting is if you look at the startups in the IT industry, and I'm sure most of you want to run towards creating a startup, and that's great. I think you should do it. What's very interesting to look at the numbers is that in information technology, only 37% of finance, education, real estate, all these fail also at more than 50% after 4 years. So you can see that in information technology, you got 37% of companies still operating after 4 years, right? So that's 63% of companies failing. So we've got 60% of projects failing, 60% of startups failing. And there's a very good reason for that, is that we have ideas and we think we know something, and then we try it and then it doesn't work. And if you're a startup, then you're getting money from investment companies to fund the project. And because that money is borrowed by someone, they want to get returns. So if it fails, you want to fail quite early so that you can give the money back, or what is left of it. You don't want to keep on dragging on a company that's failing until it completely collapsed, like MySpace did. But in this case, the money is well understood in a startup, whereas in an IT project, we never thought about this. We never thought about failure, and we never think about cost. We never think about how much thing is going to cost when we fail. Now, if we're going to fail anyway, and we're always going to fail as the most likely outcome, 60% of the time we'll get it wrong, then really what we're looking at is not really useful to call it a failure. What's useful is to call it a learning. It's a learning experience. Every single time you try to build a feature and your users hate it, chances are it was not the right feature to build. I think we've had the case recently with one of the social media applications where they changed the UI and the users really did not like it, which lowers the amount of user engagement, etc. But you want to be able to do each of the features you want to be building and try it out. And if it doesn't work out, you need to be able to pull it out. And we already know how to do all this stuff. Because we already know, for example, that no game that we play with our friends is based on the idea that you either win or not. I mean, there's always an end goal, right? You want to win at the end. But really, as you play a game, you have a whole bunch of rounds and you try to get closer and closer to getting the expected outcome. It's a little bit like a game of darts. You want to be able to play and you're going to approach, and some of the black parts are going to be a certain number of points, and the center bit is where people want to be. But I don't know how the points work because I've never played that game sober. But it's the kind of games that we play with IT, right? We want to have a product that people like, and we're going to keep on hammering at it until we get our users happy. And that's something that we have a framework for already in science. That's already being tried and tested, right? How do we experiment? Well, before we build any prototype with any piece of software, we want to ask a question. And that question is the question we're going to try to answer by releasing the piece of software we do. For example, let's say that I'm Amazon and I want to know, I make a theory in my head that if the price cuts are written in green instead of red, I will sell more of the item I'm trying to sell. If I change the color, I'll get more sales. Once I've got that question, I do some research to see if no one has told you in advance that red and green were bad ideas for colors showing prices on websites, or if it's been done in a company already, or if there's any reason technically why you couldn't be able to do it. Now, once you've done that little bit of research, you can decide to construct the hypothesis. And the hypothesis will be, I should see an improvement of 5% of sales on that item if I change the color from red to green. Once I've done that, I create the experiment. So I build a bit of code, and that bit of code is going to be deployed on the server. And once it's deployed, people are going to use my sites, they're going to buy, and I'm going to be collecting all the numbers for that specific change that I made and compare them with the normal sales I have. So if my sales have increased by 10%, I will have a positive answer to my question. Yes, it helps. If it's a negative one, we know that it didn't help at all. And if I'm just going to put myself on do not disturb because my mother is calling nonstop, which is what you would expect from a mother. And if it had absolutely no benefits, then we remove it. There is no point in keeping code and code that changed if the change has no value in itself. So we can trash it out, saying it didn't work out. So we do that for experimenting with drugs. We do that for medicine. We do that with surgery. We do that with anything sciencey, and we can apply all this stuff in software. But to be able to apply that to software, of course, we can't build software the way that companies usually build software, right? The idea of a software project is the idea that you have a fixed amount of time where we're going to have that feature being built on, right? You put 4 people, you're going to build that feature, and the project is going to be from the beginning of designing that feature to the moment it's released. And after that, there's nothing, because of course, at that point, you stop that project and you move on to the next project. And the next project may have nothing to do with it. And the people may have gone, and you may have other developers that you work with. That approach means that everything is optimized for success, because there's the beginning of the project and the project is finished once it's delivered. And so there's no one tracking down if it's successful, if it's worth keeping, or how it's going to evolve, or how it's going to be maintained, because you've stopped at the moment that you've released. So the idea is to move from building project to building product, right? Your product is the fact that you're building a website selling products, selling, whatever it is that you want to sell on the internet. That's your product. The product is going to be long-lived, right? You're not going to fund the project saying, oh, I'm going to pay 4 people for 2 weeks. You're going to say, I fund the product. I need 5 developers to do all the stuff we want, and I'm going to have a fixed amount of money that I'm going to pay my developers, and they're going to work on whatever we need them to work on. It's not a project, it's a product. I keep on investing in that product. Because it's going to be the same team building many, many features, and hopefully doing small experiments like we've discussed, well, the build has to be iterative. Suddenly, we don't have a beginning and an end. We have a whole bunch of small little features that we want to deploy, and we wash, we rinse, and we repeat. We finish one, we keep on going on the other, but it's the same people that are working on the product together over time. And because there's no end of the project, because there's no end to the product unless you close the company, there's also the fact that the team will continue owning that product over each and every single of those experiments. It's very difficult to say your project didn't provide enough or didn't make enough money, so we're going to kill it because no one is there left because that project has been delivered. When you're in a product, you deliver, it doesn't work, you remove it. It's the same people. Everybody's working together to make the product better. So they're going to remove that failed experiment and move on to the next one. Of course, we need to be able to understand how we're failing. Because you need to be able to build software that measures all the things that I talked about. And those are not technical in nature. We always need to measure a lot of stuff from a technical perspective, but we absolutely need to measure stuff from a business perspective. You're selling things. Your software should be able to report in real time how much it's selling, and you should be able to link each of the releases you have to those KPIs, those key metrics that are valuable to the business. If we don't have them, we don't know what failing means, right? So before we run any experiment, we need to be able to know when we're going to stop. So here's a question for you. For those of you that already worked a little bit in IT, and for the others, I assure you that it's the truth. You will never hear any developer ask you how much money you can lose. If I make the change to my store and I'm losing 5% of business compared to normal, how much money is that? Now, if I'm thinking in terms of building each of my features as an experiment, I need to know how much money I can waste. And so the conversation has to be very different from the moment we start building software. We want to experiment by making a change. Right now, every single project people will go and refuse that failure is an option. They will not have that conversation. We're going to make the change and we'll see afterwards what happened. When you want to run experiments in a very fast way, you need to be able to say, well, how much money can I lose? Can I lose 5%? What's my turnover? How long is it going to take before I spent my $2,000 of experiment money? Because that's actual money that comes out of the pocket of the business. And so when we discuss building every single feature of what we do in a software product, we need to understand how much money we can invest in experiments. And then they're not money that are, it's not money that is spent, it's money that is invested, just like the startup. Right? An investor knows that he may lose his money, but he's investing on the off chance that one of the companies is successful. It's exactly the same thing with software. To be able to do that, we need those measurements. And all that measurement always comes down to money. So we need to be able to ask the question, how much money can we waste or can we invest in this? How much money can we lose trying out the feature? When do I cut it off? If I'm losing 5% of sales, do I leave it for 7 days? Do I leave it for 1 day? Do I leave it for 5 days? Those discussions need to happen early on, and we need to have all the metrics in our system. We need to have our web application collect all that data so that we can make the decisions as quickly as we can. We're measuring all this stuff wrong because most people don't have dashboards. Now, the thing is that you will very often see products that that vendors are trying to sell you, telling you, oh, yes, it's fine, don't worry, your site will always be on. The reality is that keeping a system running all the time, and I've worked on very large systems in quite a few companies now, require to have a large amount of information in front of you so you can understand the behavior of the system. A little bit like this dashboard. You need to have all those metrics because when you build a software and you start collecting all those metrics, you have no idea what they're going to mean or how they relate to one another. But you need to expose them because you want to be able to tweak the system as you get along, so that when you do a deployment, you, for example, have on that graph, oh, I've got a deployment, and then you can see that there's usage on your servers that has gone up just at the moment you did that deployment. Every single change of the system needs to have something that is graphed so that you can make those decisions. And we're building it wrong because when we do it sometimes with computers, we don't do it with key business metrics, number of sales, amount, average basket size, average money spent, time it takes for people to finish the buying process. All these things need to happen so that you can have a better understanding of the system. We can't run experiments and measure the outcome if we don't already understand how the existing system works. So we need to start everything by building measurements and building dashboards and building visibility and making sure everyone understands what each of those key indicators are. To be able to do that, we're releasing software wrong, right? Most releasing in companies looks a little bit like that. You have one guy pushing the button to release something, and you kind of try to figure out if it's working or if it fails. Maybe you press F5 on your browser. Maybe you have a bit more advanced. You look at the servers for 5 or 10 minutes to see if something broke terribly, and then you just let it, and then 24 hours something else goes badly. You can't iterate fast over features and over experiments if it takes a very long time to release code. Now, if there's one guy pressing the button to release and he's manually looking at how the system works, you're not going to be able to release many features. So you're not going to be able to run a lot of experiments. You're only going to manage to do one at a time. So everybody gets in a queue. So maybe if there's 3 of you, it's not a problem. If there's 20 of you, well, now you have a very long build queue and release queue. And then you have people that become responsible for releasing software in your company, and then everybody will wait on them and they'll get very stressed out. It's not a scalable way of building code. And we have a way to solve all this. Because we're going to fail most of the time, we can't assume that deployment is going to succeed and then do a rollback to the previous version. We need to be able to have feature flags so that each of the features that you're building in are continuously integrated into the same system, and you activate them if and when you want it. You need to have canary releases and A/B testing. And the idea of those systems is to try to say, well, instead of doing one release, checking if it works and continuing, maybe we'll have all the features deployed, except some users will get feature A, some users will get feature B. And because we will give a little bit of traffic to feature A, well, if 10% of the traffic seems to be functioning correctly, maybe we can increase it to 20% and then to 30%. And you do that with each of your features, slowly giving more users to each of your feature until you're happy with a feature and you can remove the older one. And that's, again, not something that people usually do because we assume that a release is going to succeed. I always assume that my releases are going to fail. To be able to do all this, we need to change the way that we're building software as well. There's a lot of orthodoxy around using agile methodologies, using Scrum, using Kanban. Everybody uses it, and yet software doesn't get delivered any better than it was 10 years ago. The reality of it is when you have a product team, if you have 12 different work streams, like this motorway, as long as everything flows, everything is fine. But as soon as someone starts getting stopped in their work, you end up with having dependencies, right? So someone on the right lane stops, which means the person behind them stops, which means the person that was trying to overturn cannot do it anymore. And very, very quickly, you end up with everybody slowing down because one lane has a problem. Yeah?
Are you sharing something? Because there's nothing appearing on my screen.
The screen, yes.
I can't see anything on the video. Can you try to reshare it?
Yeah, I can do that. Let's try. Let's do it that way.
Yeah, I can see it now. Yeah, perfect.
Okay. Did we miss the video from since the beginning?
A part of it was missing. but it's okay.
All right, so we're trying to build too many things at the same time. There's a very good saying that I read on recently that on Twitter of someone reminded me of that quote. Stop starting and start stopping. So it's the idea that if we try to do too many things at the same time, well, none of them are going to finish. You're going to take each feature, and each feature is going to take 3 months' time, and it's going to be a huge investment. So you're not going to feel good about removing it later on if it fails, because it's 3 months of investment. And so we can't iterate very quickly over a whole bunch of features if there's a huge amount of work that happens in parallel. And really, instead of working in those lanes and in those Kanban and Scrum walls where everybody has their own lane and you have 12 pieces of work at the same time and no one really knows when code is actually going to make it to the servers, we should try to have a product team work on one theme every single time we work, because we want to be able to say, well, this iteration, we're going to try to improve sales on the front page. So you're going to build a whole bunch of experiments, and your team is going to together build a whole bunch of experiments and try one, fail it, try one, fail it, try and fail it. You can't really have 2 months of development for each of those things. You need to have a couple of days for each of them. So you need to have less parallel work so that you actually ship faster, so you can iterate faster and kill faster the code that doesn't work out. To be able to do all these deployments, you need to model your code in a way that allows you to have feature flags, to compose your application differently, to enable some features if there's a feature flag, or to disable it. That code, if it's not well architected, can become extremely, extremely messy. And to be able to understand how your software works is also very messy. We don't have a good track record as developers chatting with non-developers about the business of software, or the way that we model things. And that's a French quote. Ce que l'on conçoit bien s'énonce clairement, et les mots pour le dire arrivent aisément, which translates roughly to what is well understood is clearly explained. And so, to be able to understand each of the experiments that we're going to do in our iteration, for example, increase sales, we need to be able to model how each of those features correlate to one another in English, in plain English, or in plain whatever language you might be using, so that we can discuss with the rest of the business about what it's going to do and how much money we're going to spend on it. So part of the stuff that I've done successfully with the team is to try to start the discussion by having capabilities. Capabilities are things that my software can do, or my software enables me to do. So I can watch movies in a Netflix kind of product, would be one capability. And from that capability, I can have a bunch of user stories. Each of those user stories is also an independent piece of work that I can work on, right? There's going to be, in order to watch a movie tonight, I want to see all available movies I can rent. Because I want to increase the likelihood of people watching a movie tonight, we use something called feature injection in how we model this at the language level. We say, in order to remind you at all times why it is that you're building something, and I want to see all the available movies I can rent, is the implementation that's going to be able to answer the primary need, which is watch a movie tonight. And from that level, we go to the next level, which is we give a whole bunch of examples of what could happen, so that we can validate our software actually works, as opposed to just put it live and hope there's no bugs. So we can start writing little examples that give us, for example, given Anna's a valid account and Star Wars Episode 4 is available, when she logs in, then she can see the list of available movies, and Star Wars 4 is in the list. So you can start collecting a whole bunch of examples like this of how the system is supposed to behave, so that you can fail very early, for example, in your tests, if that test is not, it does not pass. We ended up with something that looked a little bit like that. I'm not going to get too much into details, but the idea was that we had the capabilities of the big pink areas. And then they branch into user stories, which themselves branch into features, and we put big green arrows on them, to let the rest of the business know how quickly we were building code. And we were drawing all over the place because drawing is fun. Another approach to the same thing is called impact mapping by Goshko Hadzik. I think the ebook is online for free, so you can go and download it. And he works a little bit on the same idea. He starts by having the impact that you want all your changes to do, which is 1 million players, for example, in a game, in an online game. And then it looks at the people that it tries to target, for example, the players. And then it has a bunch of capabilities, recommending, posting, inviting friends. And then each of those then go down into various other items. And the idea behind this modeling is to try to keep your eyes on the ball, as the expression says, is the idea of always trying to understand that we have a goal to achieve, and every single piece of software we're doing is an experiment in one of those things that are connected to that goal. We try, we see if it works, and if it doesn't work, then we move on to the next one. To be able to have all this code and this design and this model, well, currently we don't know how to do this very well either for testing. We don't know how to test very well. I asked my Twitter followers if they were doing TDD. 65% of people say they're doing TDD all the time. What's very interesting is that it's about 17% plus minus a few that have moved on to another testing style. And so unit testing is a great way to write code that tests your code, so that you can try and make sure that it is it does what it's supposed to be doing. Unfortunately, unit testing is very technical oriented. Now, all the stuff that I've told you about until now are about building code to achieve a business purpose, building small experiments that we want to measure and succeed or fail very quickly. And unit testing requires, at the traditional level, is a very technical oriented. I write a class and that's going to test another class. And it has its uses as is. But when you try to build software at speed, the idea of writing one class with one test class and do that over each of your project makes changing your project very hard, because you now have twice or three times more amount of code to change when you do large refactorings, even though you may not change the behavior. So some of those traditionally built unit tests are slowing you down. And so I'm not sure if they're dead, but you end up with things that you may see in your code bases as you start writing unit tests. You'll see that if there's a test per class, you probably have a problem. You probably have way too many tests for things that you may not need to test. That code over time, and this is really key, software development is not about how you build the code in 1 month. It's about how that code survives for 2 years. And the longer you work on projects, the more you know that code tends to rot when it's not tended for on all projects and all kinds of companies. And so the first thing that goes is the quality of the test itself. Because it's a test, we allow ourselves to write code that is significantly less good quality than the actual code we're testing. So you end up with lots of copy and paste and codes that just get copy and paste over and over and over again. You end up with test classes that are 200 lines of code, which make changing anything in the original class impossible, because changing the test would take too long. You introduce too many abstractions just for unit testing. At that point, each class has an associated interface. If you're using an interface-driven language, it's really problematic, because it increases significantly the amount of code you're writing. And the only good code that has no bug is the one that does not exist. So you want to have as little code as is possible. We'll just pass on to a little bit of that, because I think that's a little bit less interesting. But the interesting bit is the testing the right thing part. Having lots and lots of unit tests do not tell you if you actually built the right thing, the thing that will make your experiment succeed. So we're also not going to go too much into details, but I built an approach to doing testing, which tries to test everything at the user interface level using specifications. So in order to and the given when then that I showed you earlier, we transpose that in code, and that testing code deals with each of the components we're building. And because components are mapped to the diagrams I showed you earlier, a component kind of match with an experiment and a feature set. It's a bunch of components that consist that are a feature set. So when I want to experiment on a new feature, I plug in a whole bunch of new components, I activate them when I want to test them, and then I can try and see if the numbers I get out of it are good. I know that it already works the way that I designed it, and then I can put it in front of users and try out if it actually works. There's a whole blog post series on my website on vertical slice technologies. That's the way we built it. To be able to do all this stuff, you need to have an architectural style that allows your code to be recombined like that. And so in the traditional beginning of a software career, you always end up with layered architectures. You have the database at the bottom, then you have a access layer, business layer. They all call it something different, but it's all really the same. And then above that, there's a UI. And you end up with those 3 layers, and you can look at every single technology, and most of them will have some sort of a variance on the layered architecture. The difficulty with this is that you tightly couple yourself to a system like a database. You tightly couple yourself to an architecture where you have to pass in a whole bunch of slices before you can get to your data. Cross-cutting concerns become very difficult to implement. People put validation all over the place. So as you build software, you'll see those layered architectures, and you'll see how horrible they are. I highly recommend that you have a little bit of a read on what is called the port and adapters kind of architecture, which is a symmetric architecture in which the database is not considered at the bottom, but fully outside of the application. So the idea with that is that instead of thinking about your application or your feature as a database and then a business layer and then a UI, you consider each component to have to be a little bit like a multi-plug, a plug socket. I'm not sure how you call them, an electrical multi-plug thingy where you put your phone chargers on. And it has a male where you plug it into the mains so that you can get input energy. And then it has a bunch of blocks in which you can put your charger, and that's output energy. And you can consider your application to be a little bit like that. Your application has a feature set it needs, and it can receive instructions from the outside, commands or whatnot, through a UI or through an HTTP API or through a JSON API or however, or a message on a message bus, depending on your architecture. And on the outside, it also has a standardized interface where you can plug in a database. And if you want to change the database, it's not a big deal. And if you want to plug in a console output instead, you can do that. This allows you to componentize your application, to have little bit of features that are self-contained that you can pull in and pull out without taking large dependencies on everything else in the application. If you don't have something like that, you can't build an application where you can enable and disable things very quickly. You need to have a way to enable and disable all these things. So for example, this is as long as we still have the screen shared, this is a movie browser. It can receive a whole bunch of instructions through HTTP.
I still can see your screen.
Okay, fantastic. So the movie browser component would be receiving HTTP requests, probably from my TV or my phone or whatever. And it would persist the fact that I watched a movie or bought a movie, either to an in-memory persistence or an in-memory database. When I run my tests, I want my test to go fast, so I create a persistent that keeps stuff around in memory. And when I'm deploying it on the server, I want it to be persisted to a real database, Mongo, whatever is trendy these days for document storage. But the idea is that you don't implement, you can replace the whole movie browser without changing any of the interfaces around it. You can swap it for another component because they have a standardized set of interfaces for inputs and outputs. And because of that, you can experiment by creating a different movie browser, plug it in to the original one, check if it works, and if it doesn't work, you pull it out. You can build all this stuff as part of one application. You can have a whole bunch of features, and each of them is a component, and each of them has inputs and outputs, and they all wired up when you start the application. The majority of frameworks out there have the notions of middleware or components or plugins. They all work kind of in the same way. They contain all your components, and you can run them into one server. One of the beauty of this architecture, as you need more scale, is that you can start splitting out part of those components because of the way they're built, so that they can start talking over the network to one another as opposed to be in one big process. So we can start with a port and adapter architecture, build it as a monolith. So build it as one big system or service that contains everything. And then if it's been designed that way, we can start splitting them out onto other servers reasonably easily. We're not just building and we're not just testing and we're not just specifying and we're not just measuring wrong, we're also social hacking it wrong. When you build software, when we build software, we think that somehow we're going to be able to do the software differently than the rest of the business. And this is probably my sad note of the talk, but there is the Conway law, very important law, that says organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. What that means is that your software will look exactly how your company is organized. I just showed you the port and adapter model where each component is isolated and independent and talks and does not require the rest of the system to function. You will not be able to build that kind of architecture if your company is a big top-down bank that has 3 levels of managers, one team that releases software, one team that decides what software to build, and another team that may do half of the development for the UI and another team that does the backend. Because if you do that, then those teams will reflect the way will reflect nearly one-to-one how the code gets written. So if you want to be able to build software at speed, you need to rethink also the way that your teams are organized and the company as a whole. And that's a big challenge because I don't think you can do one without the other. And I've been doing this stuff for 20 years and I've never managed to do one without the other. Someone may be managing better than I did, but I couldn't. So we're building that part wrong, and we're also building it very wrong because we accumulate ways for teams to work based on previous experiences. There's a lovely experiment that was made with monkeys, and they put monkeys into a research center, and they have monkeys at in 5 or 6 monkeys. I can't remember exactly. You can check it online. It's a very well-known experiment, and they put a ladder, and they put bananas at the top of the ladder. Now, scientists back in those days were probably a bit evil, but every single time the monkeys would get on a monkey would get on the ladder, all the monkeys would get electrocuted. They would receive an electric shock. So as soon as one monkey goes up, all the monkeys get electricity. So, they do that 2 or 3 times, and they understand pretty quickly that if anyone goes up, then they all get a shock, which leads the monkeys very quickly to start beating up any monkey that tries to go up. And they keep on replacing one monkey at a time. And after a short while, there is none of the original monkeys. And they've removed the electric shock system so that the monkey could go and get the bananas. But because because that small society right there is used to getting a shock whenever someone tries to go up the ladder, even a new monkey that has the whole group of monkey with none of the original ones will still beat one another if someone tries to go up the ladder. And when we build teams in existing organizations, we drag along a huge amount of existing behaviors that only exist because someone addressed a problem a very long time ago, and everybody keeps on repeating that over and over again, not remembering why they do it, which ends up with we already did it that way. We always did it that way. So to design good teams, you need to start with we need to start with a null team. The null team is a team with absolutely zero design, zero rules. That's what we did with the team that is behind me. And we decided, well, why do we have all these rules and the ways that we work? But why don't we restart at zero and only create rules when they are needed? Start with nothing. Every time you have a problem, you create a new rule to try to address that problem, because each rule is expensive. Mentally, the more rules you have to follow, the harder it is to live a happy life. So we wanted to have as few rules as possible, but no less. And so we created a team, for example, that was doing mob programming. We didn't pair program. 6 people were building code on one computer at a time. So an awesome practice that I really recommend that you try. And we completely created a team that worked differently from any other team that we ever worked with. And you can only do that when you, oh gosh, I paused. I had longer hair back then. And we only created rules as we needed them. We created diagrams when we needed them. We created practices. We created visualizations. We only created things that we needed as we needed them, so we could stop dragging along all the history of the company in our team practices. And we ended up with a much happier team that could build software much more easily, even though we did nothing like the rest of the business. There were 6 of us on one computer. We only built one thing at a time. We built a componentized architecture. We didn't have multiple staging environments and all, because we dispatched traffic dynamically. We did a whole bunch of stuff that no one even thought of doing because it wasn't done that way. And I think I'll finish on this. All this is really what agile development is all about. If you research a little bit agile practices, and I'm sure you will, because no one touches a keyboard without knowing about Scrum these days. But the original agile methodology was, agile principles were there to allow us to rethink how we build software to make the best software we possibly could. All the tools that were given were just, you know, a hint. And so this is by an extension of something Alistair Cockburn says, which is one of the guys that signed the original manifesto. And really, all these practices that you learn, all the things that for example, I recommended using in this talk, they're just recipes. They're recipes that worked for me. I know how to use those recipes and make good food. And the first step, of course, is to learn the recipe and try it out. See if you manage to cook it without killing anyone. Then you start, for the same kind of food, you start going through other people's recipes and compare it with your own. And you keep on doing that. And towards the end, once you are fluent in a bunch of recipes, you kind of mix together the food in roughly the way you think is going to be good. And that's the final stage of agile. That's agile maturity. That's where you want to be. It's the final stage. If you ever get there, is a level of fluency and intuitiveness where you can't say what you're doing, but you kind of borrow and blend. And I'm telling you to borrow and blend from all those ideas. You can change absolutely everything. You can change everything that we're doing with software. You don't have to follow all the rules. You just have to learn all the recipes for software design, for company organization, for social organization, for testing methodologies, for the way that you describe the language, and for the way that you build the software. We give you a whole bunch of tools, a whole bunch of recipes. It's up to you now to go and cook a lot, mix it up, and hopefully cook us the next generation of delicious software. I've got nothing left, Sam.
Thank you very much. That was very, very informative. And a lot of it really did remind me of quite a few places I've worked in. We've got a few questions. One of them is, what is the difference between the testing that you were showing and the cucumber methodology of given, when, then? I think it's practically the same thing, but I'll just let you confirm that.
Yes, I mean, you can do given, when, then in any piece of code, right? But if you use things like Cucumber or other specification-driven development tools, you have a much closer mapping between the code and the given, when, then that you write with the business. And ideally, you want to be writing those given, when, then with someone from the business to make sure that you understand those comments and use code as the source of truth for these things. So it's not so much, it's anything that is specification-driven development or acceptance test-driven development is going to be within those given, when, then. The important bit is to put the language of the real world outside of computers as the core of how you do your testing. If the business can't read the code and understand it, then you went too technical.
That's very true. The next question is about the hang on. Yeah, so they're asking about the culture how were you able to change the culture for you to be able to say, look, we're not going to inherit these bad habits, and we want to be able to basically try things our way? Because I think they mean that it's very, very hard to change a business way of thinking or way of working.
It's close to impossible, which is why I said is probably the negative part of my talk. But so I was having dinner with Tom and Mary Popendiak. They wrote a book that you may want to read, which is called Lean Software. Lean Software. I can't remember the exact title, but I'm sure you can find it online. And it was basically, it was about 10 years ago. And I asked Mary, I said, well, Mary, I really believe in all the stuff that you teach us, but how do you change a company? Because the companies I work with, I tell them they need to change, and because I'm at the bottom, no one is listening. And she said, well, more or less you can't. There's only two reasons why a company will change its behavior. The first one is because it's not the market leader and it wants to become the market leader. So it needs to throw caution to the wind and it needs to go fast. And for that, it needs to abandon some of its existing rules. The other alternative is if a company is losing steam very rapidly and losing its position in the market, in which case they'll also accept change. Now, the best you can hope for in a company that has such an organization that you don't really enjoy is to make small improvements. We had a very lucky escape in the sense that in that specific team, the previous project we worked on stopped working, and the way that we were doing, we didn't have any consumers anymore, so we had to drop a couple of months of work because of very, very spurious architectural reasons. So we decided to rebuild something new, and because we had a whole bunch of problems with the way the team was organized, we kind of took a little bit of freedom by sneaking in, booking a meeting room back to back continuously for 2 months. So we need to have a team room. We can't have team rooms because they don't do team rooms. So we're going to get our facilitator in the team to book us meeting rooms so we can work as if we had a team room. And we did that every day. And because we provided results, because we were delivering continuously and constantly new features at very, very constant speeds that no other team managed to do, it gave us a little bit more leeway to then get a team room when some rooms became available. And I think that if you're in the long run and you expect to stay for 10 years in a business, then that's the way that you attack the problem. You find a way to crack open one bit that you want to improve. You try not to ask too many permissions, as long as you don't get too much in trouble for it. And once you've managed to start delivering on those, then you can say, well, yes, but it's because we were doing that. So it's a little bit the same as companies telling you, oh no, you can't do pair programming because it would take twice as long to do software, or would have twice less hands. Well, we're developers and we are the ones that know how to build software. So if we say that this is how we're going to work, we don't need to ask permission to a manager to do pair programming, because what's important is to deliver the software you want, not deliver it using this keyboard color because that's what the manager wants. And so you have to take a little bit of freedom, apply what you know you need. And if the company can't trust you with that, then unfortunately, you're not going to be able to do very much at all. So write open source code in the evening to compensate. I don't know, but it's not an easily solvable problem. No one has a silver bullet.
Fair enough. Basically, ask for forgiveness rather than permission.
That's right.
So those were the main questions. Thank you again very, very much for joining us. It was extremely informative, especially for people who are just starting off in their careers. So gives them a little bit of a high-level view of the pains and frustrations that people go through and how to build software in a purely agile way, really.
And don't hesitate to ask any questions on Twitter. I always answer on Twitter.
What we'll do next is we'll just basically tweet you saying thank you, and any questions will be tweeted to you.
Okay, fantastic. Well, thank you very much for having me tonight.
Thank you, Seb, and thank you all for watching. Have a nice evening.